I want to remind you, in grade 9, if I wanted you to make a graph of 3x plus 6 equals y, you made one of these, right? You called it a T-chart, I call it a table of values, whatever, right? That was grade 9, yeah? And then in grade 10, you've learned some other ways you can do this. The first way we learned in the very first lesson of this unit was x and y intercepts. And that was x0 and 0y. And what did we do with those numbers? We plugged them in to, we plugged them in to x and y. And that got us 2 points that we then connected the dots. Now, essentially, when I'm plugging these in as x and y intercepts, isn't that the same as doing a table of values? So we really didn't learn anything new with x and y intercepts, did we? Except that every single x-intercept is x0 and every single y-intercept is 0y. But other than that, that wasn't anything new, right? And then the next thing we talked about was y equals mx plus b. And that told us that b was the y-intercept. And then from there, we could count rise and run to get slope. But we remember that we still have x's and y's, just like we had in grade 9, right? Nothing new. Except I don't need a table of values anymore because I have a starting point and I can just count for the slope, rise, run, right? Now, when we did that, we had to learn all about how slopes can be positive or negative or infinite or flat or zero. And we had to learn there's a whole bunch of different ways we can write slope. Rise over run, y2 minus y1 over x2 minus x1. Change in y over change in x. Change in dv over change in iv. Rate of change. There's a whole bunch of things we could do. But they're all the same thing, right? And we still got back to x and y. Now, the mistake most of you kids make is you forget that b, it is the y-intercept. So b is really the point on the graph, 0, b. The b is the y-intercept, or the y value that goes right there. Is everybody cool to that point? Now you will notice that everything we've done so far does a lot of focusing on intercepts, yes? Now, if I were to draw this line, how many intercepts are on that line? 2. How many other points are on that line? Infinite. So if we had a way that could use all these other points, it would be pretty useful, wouldn't it? And that's what we're going to learn about today. We are going to learn about point slope form. Or, if you like saying slope-intercept form, some people call this slope-point form. They're the same thing. Now, on Friday, I showed you guys what this was going to look like. And we got a big white space here. We're going to use that right now. Point-slope form is this. Now, sometimes you'll see this written this way. Y minus y1 equals mx minus x1. And you will notice the x1 and the y1 are in the same spot, yes? Now, all you have to remember about this form, even though it looks ugly, is it's made up of the same stuff, yes? X's, y's, and a slope, right? Now the x1 and y1 are both points on the graph. Now what I mean by that is just like, and don't write this down, if I tell you this in slope-intercept form, 3x plus 6, do you know a point on the graph where you could start that line? What is it? 6 on which axis? The y-axis. Because we have the y-intercept, yeah? Well, in this form, these 2 points, whichever way you write it, that's our starting point. But you'll notice it's not 0y. We're not throwing out the x. It's actually part of it. Does everyone see that? Now, you also need to notice this. What is that sign right there in front of both of them? Not subtraction. What is the other thing that sign means? Negative. And negative means opposite, yes? So, if both points on the graph, but they're opposite, and I'll show you what I mean in a sec, but they're opposite because of the negative sign. And here is what I mean. Y minus 7 equals 2x minus 3. Now you can quite plainly see here, I have a y and an x and a slope, yes? So it's almost the same as slope-intercept form, where we have y, x, and a slope, right? And we start from the b. But we can't start from the b now because we've got this extra number here, yes? So there's 2 things I could do. One, I could make this look like this. What would I have to do to make this yellow equation look like this? What has to be gotten rid of? I got to get rid of the minus 7. I got to move it away from the y. And what else has to be gotten rid of? The brackets. So I could do algebra and I'd be okay, wouldn't I? It would give me a y-intercept and I could count from there, yes? But that's extra steps. From here, we can do it. We know that x equals the opposite of 3. So what would be the point on the graph we would use? Positive 3. And y equals the opposite of 7. So what would be the point on the graph we would use? Positive 7. So where would I go on this graph to start this line? 3, 1, 2, 3, up, 1, 2, 3, 4, 5, 6, 7. There. And then where do I count from there? My slope, up 2 over right 1, or down 2 left 1. Everybody cool? So I go up 2 over 1, or down 2 over 1, and there would my line.
So the 3 and the 7 aren't the intercept?
The 3 and the 7 are not the intercept. They are the point in point-slope form.
So is this a point on the graph?
The slope is 2, where m lives. Yes, it's any point on the graph. Does everybody understand? Now notice the formula says we have to use the opposite. So let's reverse the thing. What if I told you I had this line? That point right there is 3, 1, obviously, yes? 3, 1. And I've got another point at right there, which is 1, 0, yes? What's the slope between that? I went down from 1 to 0, so down 1 and left how far? 3. From 3 to 1? 2. So that slope, my m equals 1/2, correct? So where could that go in this form? It would go for the m. So I would have y minus y1 equals 1/2 x minus x1, correct? Now, is that a point on the graph that I know, 3 and 1? And that 3 is an x, yes? And that 1 is a y, yes? So what would I put in here? The 3 would go there, -3, and -1. Everybody understand? What if the point was here, which is 3, -1? What would go here? Oh, and you did this backwards, everyone. The y is the -1, and the x is the -3. Now what would go here? So the y is now -1. So it would be y plus 1. 1/2 is still the same, because we've dropped everything down. And it would be x minus 3, because we got to do the opposite of that. Is everybody cool? You are. Don't feel bad. The shortcut is you just do the opposite. Why it works is all algebra. So here's what I mean. You know that this point on the graph here would be 3, 7, right? Because it's the opposites. Everybody cool? Now, that is an x value, correct? So if I put 3 there, and that is a y value, and I put 7 there, right? 7 minus 7 is what? 3 minus 3 is what? 2 times 0 is? So 0 equals 0, right? Now, look what happens if you forget to make it opposite. If you look at this and you're like, oh yeah, Mr. Myers says these are the points on the graph. So I'm going to do -3, -7, because that's what it says there. Which some of you might do, right? Because you stopped paying attention when I said x and y are points on the graph. So you're going to use -3 and -7, aren't you? So this is an x value, correct? So I would put it right there, wouldn't I? What's -3 minus 3? No. -6. What's -6 times 2? -12. This is a y value, right? There's a y. If I put -7 there, what's -7 minus 7? -14. Does -14 equal -12? No. So that is why you have to be careful. You have to remember that it's opposite. Everybody good? Prove it. What are the attributes of this line? So I want the slope, and I want 1 point from each of these lines. Okay? Go. Shouldn't take very long. You're just writing 2 values for each. If you get stuck, what should you do? Go on to the next one. Fill them all in first, because you know I'm going to go over this, right? No, slope is normal. All right. What is the slope in the first one? -2/3, which means if I know my point, how would I find the next point? What are my options? I can go up 2 and left 3, or down 2 and right 3. Okay, and what's the point on the graph that I would start at? 1, -2. Does everybody understand? So if I was going to graph this, I'd go to 1, -2, and I'd count up 2 and left 3, or down 2 and right 3. Is everyone good? Everybody? Okay. What's the second one? What's my slope? So my m equals negative 1 over 4. What are my options? Once I know my point, down 1, right 4, or up 1, left 4. And what's the point I could start at? Negative 3, 4. Everybody good? Okay. What's weird about 3? There's no m, but there is an m. What's the number that multiplies like m multiplies that we never write? 1. So our m equals 1. What's our point? Negative 2, negative 1. Perfect. What's our slope in 4? 1 over 2. So what are my options? Up 1, right 2, or down 1, left 2. And what's the point? It's tricky. Negative 4 and no, 0. Because y minus 0 would stay y, right?
But is it the I didn't write the other number before, like the number you don't write is 1?
Yeah, you don't write 1 when you're multiplying. What don't you write when you're adding?
0.
Because adding 0 is the same as what you started with. Okay, what about 5? What's my slope? Negative 1. So what are my options? Up 1, left 1. What about up 7, left 7? What about up 23, left 23? If you like. If your graph was that big, you could do that. Everybody cool? And what's the point I'm starting at? Negative 5, negative 3. And the last one's easy. We go back to what the very first one was. What's our slope? 4/5. And what's our point? 1, 10. Is everybody good? Everybody sees how it's quite related to slope-intercept form, yes? If I wanted to, y equals mx plus b, y equals 3x plus 6, right? Isn't this y minus 6 equals 3x plus 0? 0, positive 6 for the for the point we know. B is the y-intercept. Isn't the y-intercept 0, 6? See how they're very closely related? Everyone is good? They're made up of x's and y's. Where do we get the x's and y's? From the coordinates, right? And the slope is rise over run. We're all good, right? So even though it looks freaky-deaky, it's not. It's the exact same thing. Everyone's cool? All right, turn the page over and let's have a look. Now, is this in point-slope form? Yep. So what do I know about this line? Slope is 2/3. Now, 2/3, as soon as I see slope as a fraction, what's the 2? Rise. What's the 3? Run. What direction is rise? Up. If I'm going up and my slope is positive, then what's my run? Right. If I go down, then what's my run? Left, to keep it all positive. Everybody cool? And what is my starting point? Negative 1 and positive 2. Negative 1, positive 2. And my slope, down 1, 2, right 1, 2, 3. Is that correct? Down and right, is that correct? No, it needs to be down and left 1, 2, 3, or up 1, 2, and right 1, 2, 3. And then I get my nice straight line. Everybody cool? Now look, what is this point right here? You can count. It's 1, 2, 1, 2, 3, 4, right? 2, 4. Everyone agree? Everyone's cool? What letter does that 2 represent? What letter is that? So what could I write there? 2. What letter does that 4 represent? What letter is that? What number could I write there? 4. What is 4 minus 2? 2. What is 2 plus 1? 3. What is 2/3 times 3? What happens to the 3's? They cancel out. So what's left over here? Just the 2. Does 2 equal 2? So is it easy to check if I did it right? I take any other point and I use the x and the y. So, sorry to interrupt, Nathan. Carry on. I was just about to get out of my mind. What's this point right here? No. -4, 0. What letter does that represent? X. What letter is that? So what number could I put there? -4, correct? What letter does that represent? Y. What letter is that? So what number could I write there? 0. What is 0 minus 2? -2. What is -4 plus 1? -3 times 2/3. What happens to the 3's? Cancel, and I'm left with -2, right? Does -2 equal -2? It does in my universe. So is this line graphed correctly? How long did it take to check? Well, when you're playing 2K19 or doing whatever those two are doing, then it will take significantly longer to do math. What they really aren't doing is taking hints very well, because I've been talking about them for a little while, and they've just noticed and have shut up now. So while they may be okay at math, they are crap at taking hints. I think so. Heather. You shouldn't need to check it more than once. So, what should I not need to hear from you? Do it right? Even the computer doesn't want to hear if you did it right. So, let's look at this next one. What's my slope? -2. But it's not really -2, is it? It's -2 over 1. So there's my rise. There's my run. Since it's negative, if I go up, where do I got to go to run? To the right. Up to the right. If I go down, where do I got to run? Down and left? Up and right? Up and left, or down and right. Remember how I told you we'd do in 3 days of slopes so you would really understand it? We're still having some trouble with it, right? What is my starting point? -5, -1. -1, 2, 3, 4, 5, -1. What are my two options? Up, how far? 2, and then left 1, or down 1, 2, and right 1. There's my line, correct? Now, the point I had was -5, -1. Let's check with this guy. I went over to the right 1. So what is this guy's x value? -4. What is his y value? -3. How do I check? What letter does that represent? X. What letter is that? X. So what number can I write there? -4. What is -4 plus 5? +1. What is +1 times -2? So the right side of my equation is -2, yes? What letter does that represent? What letter is that? What number can I write there? What is -3 plus 1? So the left side of my equation is -2. Does the left side equal the right side? So did I graph it correctly? Yes. Is everybody good? You can all graph a line now in 5 different ways. 4 different ways. Table of values, x and y intercepts, slope intercept, and now point slope form. Yes? All right, now, the next question you will notice adds another concept from what we've been working on. Right? What is the new the concept that we already know that's been added to today right now? Perpendicular lines. That word means something to us. What does it mean? Opposite and reciprocal what? Slopes. So, I have 2 lines. I got line 1, which will be black, and I got line 2, which should have been red because I tapped red, but it didn't change. Line 2, which is red. What do I know about their slopes? I know line 1 is 2x minus y plus 8 equals 0. Is that in a form that I can work with? Can I make that into a form I can work with? How? If I get y by itself, I can work with that, can't I? So if I move the y over there, what happens to it? I get 2x plus 8 equals y. Is y by itself? So what do I know about line 1 now? B equals 8. And what's my slope? 2 over 1. Could I graph it now? Okay, let's do it. Where's the y-intercept? Up 8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. Everyone agree? Then I could graph it, right? Slope of +2, yeah? So up 2 and over 1 is going to take me off the graph. Should I do that? No. So I'm going to go down 2 and left 1. And how long could I keep that pattern going? Forever. I'm going to do 3 because it's easier to connect three dots in a straight line. Everybody happy with that? Yes. That's one of the next things I was going to ask. Is this the exact same thing as that? Of course it is. Y is isolated. As long as y is isolated, the number with x is the slope. The constant is the y-intercept. Right? But we're only halfway done the question, aren't we? We got a second line we got to work on. Now, what do we know about that second line? It's going to cross at the y-axis. Where is the y-axis? It's right here. If they're going to cross there, then what do they share? They share the same slope, but they're perpendicular. Opposite and reciprocal. What do they actually share that is the same, though? That point. What is that point? 8. So line 2, we know, is y equals, what's the opposite reciprocal slope of 2? -1/2 x. And what did they share? Y. Y is this +8 in both. Because it says that they cross at the y-axis.
Is that necessarily true always?
No, of course it isn't. What if this line, this whole thing, were over here? They would still cross, but they would share that point, which is no longer 0, 8. What's that? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11, 8. Now, it's like you're in my head. Can you use what you just learned right now to tell me the two equations? Using this form. What is line 1 now? And what is line 2? Yep. Because they share that point, so it has to be the same in both, and only the slopes are flipped and opposite. Does everybody understand point-slope form? Now let's think about this. Does point-slope form work on every graph? What if I had distance and time? Oh, wait, that was a stupid one. Distance and time. Could I still use point-slope? But it wouldn't be x and y. What would it be? T and D, right? Everybody cool? Okay. And you see how it's more useful because you can use it with any point on the graph, including the y-intercept. Whereas the y equals mx plus b only works with the y-intercept. Everybody good? Great. Try page 208 and 209 and 210. It seems like a lot of work. Why? Lots of pictures, and to describe the graph, lots of words. But really, every word is describing what? Either an x or a y, or an independent variable and a dependent variable. Right? Go.